Hey guys, so today we are going to do everyday types, and first of all, very happy New Year to all of you, and I hope you celebrated it well. I did, um, and I hope that all your goals for this year do get completed, and uh, we all are working really hard. We have worked really hard the last year, and we will work really hard this year too. And uh, I hope we achieve a lot this year. Um, without further ado, let me just transition. Yep, I actually like this feature a lot. From the time I found it, like I'm like, oh, this is great. Um, so this is everyday types. So we are aware of JavaScript types. So we'll go very quickly through it and we'll just finish it up. So we have string, number, boolean, all the primitive types. Then we have arrays. So this is how you represent a type. Like if an array. So like array of strings, array of number. So I guess um, they have made object of type any. So now object does not know if foo exists on type any or not, because it could be of a type any, and we can add uh, of type number. So no implicit any. If we come to no implicit any, then it's basically tag in the TypeScript config file. We saw what TypeScript config is in the uh, last or the previous one, like the previous or the previous to the previous video. Uh, there have only been two, and yeah, so basically you add this tag and you add this key to true, and then anything like normally like with without this tag, if you write let my name and omit this part and write is equals to like a better example would be if you write a function and have a parameter there, and you do not define the types of the parameter, then the type of the parameter will be considered as any, because it's not specified. Like that parameter could be a number, that could be a string, or anything. So basically anything. That's why it's any. And uh, TypeScript will do that automatically, but with no implicit any tag uh, key in the uh, tsconfig file. That would not be the case, and you will have to actually tell TypeScript that uh, uh, that what will be the type of the argument. So that's what the implicit any does. It's very like yeah, like oh, they have given an example. So with no with no implicit any false, this will work. But if it's true, then this will give an error because it is implicitly made to be any, which is not allowed. Simple, easy peasy, lemon squeezy. Uh, Type annotations of variables. So we have seen that. We have seen that type is inferred. For functions, we have to add type like this. Now, this is a number, so that will give an error. Return type element. So you also have to tell JavaScript what a function will return, because if not, then that will be a problem. So I don't know why I've became so monotone while speaking that. So that's why this is how we tell that what the function will return, what type the function will return, and that's all it. Anonymous functions. So names is an array names dot for each function uh, s. It's an this is an anonymous function, so it does not have a name. This function console log s dot to uppercase. So here we haven't specified that what the um, type of s. So uh, uh, not, and so as this is a string or like array of string. So for it each this will be s of type string implicitly. So like that's discovered implicitly. Though a lot of time when I have used the map function, JavaScript does not detect that. So be careful with this, and then it does not string does not have like two uppercase, so the C is capitalized, so that's the problem. Uh, Object type. So basically, type of an object. You like we saw how we write interfaces and how we write types. So uh, basically, if PT is an object, then we write its type in form of an object, and where we write for every value. So PT, I can say from this code that PT has a value X, which is of type number, and a value key X, which is of type number, and key Y, which is of type number. Again, so optional properties, uh, object first, string last. So in TypeScript you can also give in optional properties like this. So this will say that basically last is not required. So uh, in that case you can you can have the object could also be an object with the key first and the value of first, and the object could also be key first, value of first, a key last, value of last. So like this, like this could also be the object, this could also be the object. So that's last object dot last dot to uppercase object is possibly undefined. Okay, so in like TypeScript also checks this case where as this last is optional, so TypeScript will throw an error where it will tell you that object is possibly undefined because possibly you might not pass last. That's not a requirement. So in that case you will have to like you can comment this code out and you have to check if last is undefined or not, and then do that. Union types, we saw what union types is. This is basically union types. So we can enter a number or a string, and this works. But this does not, because we the type that it accepts is a number or a string, and the union is done by a straight line. Um, okay, so working with union types. So property to a does not basically to uppercase does not accept is not, you have to take care of all these types. If you are using union types, if you are using conditional types, conditional arguments, then you will have to take care of if the type is correct, or if the um, argue parameter exists. So that's what you have to take care. And so in this case, for number, that two uppercase will throw an error. So you will have to check for if the type is string, then you can do to uppercase, or else you can leave it. uh, Array is an array, you can do to check if it's an array, or and if it's not, then you can do it like that. We can do it like that. I'm saying you because I'm also learning. uh, I though I know a lot of this, but obviously I haven't read the docs, and I know it from practical stuff, and it's very good. It's a very good practice to read the docs. I honestly say it's a mistake that I did, where I was in a hurry, and I didn't read the docs, and I just learned it through practice. But reading docs is something I recommend a lot. Get first three X number. Yeah, so yep. So now you can see that slice works on number and or array of number and string. So uh, we don't face a problem here. I'm actually getting a call there, so that's why my I sometimes went that side, but leave it. Uh, Type alias point. We are defining a type point. We can also do this with interface. Interfaces are a lot much more preferred. So, and they also, like in the previous uh, TypeScript handlebook, I guess, video, they said that use interfaces, use types whenever you don't find a way. So for this case, we'll probably use the interface. Uh, Only in this case you use types. Like if you want to define a type, you define it like this. Okay. We can also define like a type that is a reference to a type. This is generally done in codes there where they want to be specific. Like it's a string, but what type of string is like it's user input and touch string. So they do some things like this, and it's good for maintainability. So developers that look into that code later on can understand what's being done. But I think for in if you are in that case, you should work like that. The code base should be humongous for using that. I don't recommend it. I don't recommend using TypeScript on small projects. Start with medium to large projects, and when it's humongous, use like features like that. Those. Okay. Just like we use type alias server, the example just works just as if we use an anonymous object type. TypeScript is only concerned with structure of value we pass to print code. Yep, it only cares difference between type aliases and interfaces. Interface animal name string. Interface beer extends animal honey type beer animal and extending. Basically there are syntactical differences, so though they only recommend that you use interfaces and not types. Adding new fields to existing interface window title string type window title string interface window ts TypeScript type window, so you can make duplicate types, I guess. um okay. Type assertion. Okay. Sometimes you will have information about the type value TypeScript can't know about. some example, you are using document element. TypeScript only knows that this will return some kind of HTML element, and but you might know the page. Yeah, basically they are saying that sometimes you might know better than TypeScript, obviously, because when you are selecting a canvas, you know that you'll get a canvas. So, but TypeScript knows that document.getElementId will return a HTML element, which could be anything. So, you can easily like assert the type here like this, like type annotation, type. Uh, A type annotation, type assertion are removed by the compiler and won't affect the runtime behavior of your code. You can also use angle bracket syntax code in a TSX file, which is equivalent. Okay, so we can also do it like this. So it's the same thing with different syntax. I do prefer it doing like this. It's much more clearer. And if you are doing React or like it, so this is much more preferred because this has different uses, like using of an angle brackets is used in generics, which we will get to, I guess, somewhere. Yeah, yeah. So this is not possible because it's a string, it's a number. Uh, TypeScript only allows type assertion which converts a more specific, less specific version possible. Sometimes this tool can be too coercive as and will allow more complex coercion that might be valid. If this happens to you, you can use assertion first to any. Uh, okay. Basically, they are saying you can read it like sometimes that could be a problem. I'm sorry, sometimes you know better than TypeScript. Never think that. Obviously, this language is designed by the brightest of people, but a lot of time they also miss a lot of stuff that is your use case. So in that case, you can uh, convert that to any and then convert it to your type. Literal types. Okay. In addition to general type string or number, we can refer to specific string and number in type position. One way to think this is to consider how JavaScript comes with different ways to declare a variable. Both var and let allow for changing what's held inside the variable. Const does not. This reflection in how TypeScript creates types for literals. Let changing string changing string equals to changing string. um, hmm? In addition to general type string and number, we can refer to a specific string and number in type position. One way to think about this is consider how JavaScript comes with different ways to declare a variable. Both var and let allow you for changing what is held inside the variable to const does not. This is reflected on how TypeScript create types for literals. Okay, because changing string can represent any possible string. That is how TypeScript describes it. And yeah, we know that. Okay, I guess. Okay, so TypeScript describes it as let and const. Okay, that's what they are saying. Makes sense. By themselves, literals are very valuable. Yep. Uh, how do you not and Simon to type hello? Oh, type. Okay, yeah, obviously. Uh, Somebody is calling me like again and again. Um, it's much used to have variable that can only have one value. Okay, so by combining literals and by union, we can use it like this. So what's the problem? CENTRE. Okay, spelling error. Numeric literal types. One way, yep, we can uh, do it like this. Basically, you can uh, it could be option of type options or auto. So yep, makes sense, makes sense. So the uh, type option, type auto, a type not accepted. Uh, Literal interface. When you initialize a variable with an object, TypeScript assumes that the properties of the object might change the values later. For example, if you wrote code like this, contra system. Yep, TypeScript does not assume that the assignment of one the field previously is an error. Another way, yeah, it will not give you an error. This is very logical because JavaScript does not allows that, and we don't want to restrict ourselves too much in like a case where we don't have a way out. We want just to be more maintainable, I guess. Yeah, maintainable. Cause request and handle request. Type string is not assignable to parameter of type get slash post. Okay. What's the problem? In the example, request the method is inferred to be string, not get, because code can be evaluated between the creation and the slash. Okay. Uh, like that's a basically if you have had put get here only, it would not have been a problem. But now as it's of type string here, that has been already defined, so that's creating a problem. You can do it through this like assertion, or you can put like type. Uh, Now you can also as const, I guess you can do it as const also, because in that case this will be of type get, because we know that we have seen that mm, like if we have a constant value, then uh, uh, so it will be of type like what the value. My God. It's difficult to speak for so long. And I am not a speaker. I am a quiet person. JavaScript has two primitive values used to signal absent or uninitialized value, null and undefined. TypeScript has two corresponding types by the same names. TypeScript has two corresponding types by the same names. How these types behave depends on whether you have strict null checks option on, strict null checks option off. With strict null checks off, values that might be null or undefined can still be accessed normally, and values null and undefined can be assigned to property of any type. This is similar how language without null checks, example, behave. The lack of checking of all these values tends to be a major source of work. We always recommend people turn on strict null checks. So you can turn strict null checks on on the tsconfig file. Um, strict checks on. So if this is on, you will have to check. If null, then do this, then all. Okay, not null assertion postfix. TypeScript has an special syntax for removing null and undefined from the type without doing any explicit checking. Writing explanation after the expression is effectively a type assertion that the value isn't null or undefined. Okay, so in this case, like instead of doing all this, you can easily like write this also, and or you can also write a question mark, so you can use it the JavaScript conditional whatever you say. I forgot the name. You can use the JavaScript feature also, so this could also be a question mark. Enums. Enums are a feature added to JavaScript by TypeScript. They allow for describing a value which could be one of set of possible name constant. Unlike most TypeScript features, this is not a type level addition to JavaScript, but something added to the language and runtime. Because of this, it's a feature which you should know exists, but maybe hold off using unless you are sure. You can read more about enums and enum. I generally don't use enums. Let's see. Enum direction up one down. Okay. About numeric enum up is initialized with one. Allow all the file members are auto incremented. Okay. Here up is value zero and okay. No. Okay. Cool. Less common primitive. It's worth mentioning the rest of the primitive in JavaScript which are represented in type system, although we will not go depth big into uh yep, we have studied both and symbol. I don't think anyone uses symbol, but I haven't personally seen in the code. Let me not just say anyone uses symbol, but yeah. So but symbol is there, just something to remember. Um, Now let's go. We are done with everyday types and for all those who joined, I don't think anyone would have joined right now. But all those who will watch this video in the later stage, please do like, share, subscribe. Subscribe. Uh, I don't think anybody will share it. Probably someone would, but I don't know. If you find the word, do what you feel like that. That's it, I guess. Sayonara, goodbye.